Yes, we can start. Okay, I'm pleased to introduce the speaker of today. Professor Xu is an assistant professor at the Department of Computer Science, University of Texas at San Antonio. He received his PhD in computer sciences in 2000 from Fudan University in China. He carries on a lot of research in the area of system-oriented security analysis and design with emphasis on cryptographic design and analysis. He has a lot of funds from agencies such as NSF, RO. So you can find many more information about his research on his website. So I'll give him the floor.
Thank you, Professor Perdino. Okay, so today I'm going to talk about policy-driven, privacy-preserving access control with mixed credentials. This is a joint work with Moti Yung from Colombia. First, I will introduce you a brief introduction on the motivation of this research, and then I will discuss some ingredients that have been adopted in this work. And I really see that this work is like the first work of a line of research, so I'm really happy about it. And then I will present you a specific product, construct, which is called assembly signatures. And then we will discuss how to incorporate revocability into assembly signatures, which is sometimes important. And then we will conclude with some very challenging open problems, most of which I have sorted quite a bit, but no solution yet. So the overall motivation is to do access control in particularly large scale decentralized systems, which is sometimes really interesting. So actually I have several things I can talk about, but I deliberately choose this topic because many researchers like Professor Lin Hui and so on, they know much better about the policy or that kind of thing than me. So I really hope I get some feedback. Okay, in such systems, overall there is no centralized authority. Okay, and each participant in the system does not even have the picture of the whole system, only a view or partial of the system. Okay. So always the service provider or the resource owner, they determine some policy based on their view of the system. And then the service requester, they have certain credentials, hopefully whereby they can get access to the resource of the providers. Okay? That is a basic functionality, but in a more kind of fancy, but should be more useful version of the picture, we want more properties. First is privacy preserving. Hopefully, the service requester doesn't have to leak what credentials they have, or not even say their identity or something like that. On the other hand, the service provider may not even know which resource the service requester have access to. So there is a notion of like a PIR, private information retrieval or something. It's kind of that. Okay, but today we are not getting into that more. And then, of course, access control should be always sticking to certain policies. This is really old topic in computer security. And sometimes the accountability is really important, particularly if anonymous access is allowed. So because the anonymity protection should not be used as a shield for doing something bad. So the law enforcement need to get those bad guys accountable. So the problem is very natural, okay, because these days like a peer-to-peer system or something like that, really like a decentralized. However, there are a bunch of literature schemes, quite many, and many of them are contributed by the peer-to community. So. But I do see that there are overall two approaches. One approach is able to accommodate many advanced cryptographic constructs. So this is many done by the crypto community people. Particularly since David Chang, and many people notions he provided, and many followers did tons of job. But somehow not so surprisingly, corrupt people, they don't consider policy, or at least not a flexible policy. They only consider policy something like you probably already familiar with, like a 1 out of 1 or 2 out of 1 at most. Okay. On the other hand, in other community, particularly in security community, they do consider very flexible policies, but they don't really take a full advantage of all the cryptographic constructs, as we will say. There are cases. Okay. So the motivation is, why don't we? The problem is well known, but we don't have a fully satisfactory solution either. So why don't we kind of unify the two approaches under the same framework? Okay, so kind of in order to do that, we will just generalize each of them a little bit. So hopefully we can achieve that. But it turns out there are many challenging problems, and indeed, I would like to say this is the first work which reflects our preliminary result, and there are many challenging problems in order to achieve the ultimate goal. So we discuss briefly the ingredients which are adopted in this specific work. The first is about the text summary about the credentials, and then a class of policies which are accommodated by our work, and then there is a cryptographic ingredient called sigma protocols. So we classify credentials into 4 categories. One is identity credential. So there is a explicit certificate like 509, so everybody knows about it. And typically, the certificate is about its identity and the public key, or sometimes identity and the public key can merge in the context of identity-based crypto, or even identity-based secret key crypto system. So there are such schemes. Okay, the disadvantage with this kind of credential is that there is no anonymity whatsoever. Okay, and then second is what we call slim credentials. So there are still explicit certificates, but they do achieve a little bit of anonymity because they don't put your real name on the certificate. So there are some pseudonym, just like your driver license. If you don't like it, you put your SSN on it, you can select a random strand, something like that. But still, the anonymity is weak because of linkability, which means if I see the same driver's license twice, then I know they are from the same guy. Even though at that point I don't know exactly who is the guy. Okay. And then there is attribute credentials, which still use explicit certificate. However, it could have many attributes, and the values could be encrypted. And then based on some zero knowledge proof or that kind of cryptographic techniques, you can show you are really the owner of the certificate. Okay, but still it's a weaker anonymity because of the linkability. However, I recently got some idea which can probably do something better, but I have not fully really investigated the details. So the last one is anonymous credentials, which have been really explored by the crypto community for a long time, more than 15 years or so. Okay, and indeed they are quite challenging, and only until like 2000 or so we had some really nice constructs. In such credentials, there is no explicit certificate, and therefore they can achieve strong anonymity in the sense that even if, say, yesterday I convince you I have certain credential, and today, so you don't even know they are from the same person. Okay, so this is really strong.